Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome back to my class. Hope you have gone through the previous videos. Uh, in previous lecture, we started chapter 7, which is rate of return analysis for one project, and we covered few basic concepts. Here is the content of the chapter. First of all, understand the meaning of ROR. We have discussed what we mean by ROR in simple terms and a proper definition of ROR. Then we see what is difference if we calculate payments on the basis of unrecovered balance or on the basis of initial amount. So both are different methods. We differentiate it between these, and we make it clear that ROR is a relative measure. On the other hand side, present worth and annual worth and future worth are absolute measures of worth. And we also made a point that ROR is a widely used measure to evaluate investment projects all around the world. Then in this topic or in this lecture, we'll learn how to calculate rate of return value for cash flow series. Then the next topic will be special considerations when using the rate of return method and how to determine multiple rate of return values. Finally, we'll learn how to calculate external rate of return. So we started with internal rate of return. That is a rate of return at which net present worth of cash flows becomes zero, or this is a rate of return that equates sum of present worth of cash inflows to sum of present worth of cash outflows. Then we gone through or discussed the relationship between present worth and internal rate of return, discount rate, or interest rate. So there is an inverse relationship between both present worth and rate of interest or rate of return. So if rate of return or rate of interest increases, the present worth decreases, and if interest rate decreases, present worth increases. And if you see, when the rate of interest is 17.25%, the present worth is equal to zero. So this rate is known as rate of return or internal rate of return. Then we interpret rate of return. Here we made a point that rate of return is the rate paid on the unpaid balance of borrowed money or the rate earned on the unrecovered balance of an investment, so that the final payment or receipt brings the balance to exactly zero with interest considered. Means that this definition doesn't state that the rate of return is on the initial amount of investment. Rather, it is on the unrecovered balance or unpaid amount, which changes each time period. So you need to keep this distinction in mind. Then we discussed an example and empirically proved the point that if we pay interest on the initial amount, we are not able to uh, repay the principal amount within the stipulated time. On the other hand side, if we pay or receive interest on the unrecovered balance at the end of stipulated time, we'll be able to recover the principal amount plus interest. So we made distinction with example here. Then we studied or discussed the economic viability on the basis of rate of return. So if rate of return is greater than or equal to cost of capital or MARR, this project is economically justified, we can accept it. On the other hand side, if rate of return is less than cost of capital, this is not a good project, we shouldn't undertake it. Then economic viability based on rate of return. Why we compare with MARR? So this is a minimum rate of return that every company want to earn on their investments, because this rate of return or MARR is important or very essential to cover their expenses or cost of the project. That's why this is also known as hurdle rate, benchmark rate, or cutoff rate. Once we have ROR, which is equal to the sum of present for which is the difference between sum of present worth of inflows and sum of present worth of outflows, or this is a rate of return at which net present worth becomes zero. So once we have both rate of return and MARR, we need to compare with them each other to make a final decision. Then ROR is a relative measure. On the other hand side, present worth, future worth, and annual worth are absolute measures because these are they give us final values in terms of dollars or euros or any other currencies. On the other hand side, ROR is being calculated on the basis of cash flows of the project itself. That's why this is a relative measure. And finally, we made a point that rate of return is based on anything or everything that is internal to the project, mean cash flows only, whether this is inflow or outflow. That's why this is known as internal rate of return. No external factor to the project is considered while calculating rate of return. That's why this rate is known as internal rate of return as well. Now, in this lecture, we'll learn how to calculate rate of return using present worth and annual worth relationship. So ROR can be obtained from either present worth or annual worth. Its calculation is based on its definition. The rate of return is the interest rate that makes the present worth or annual worth of a cash flow series exactly equal to zero. It can be calculated as follows. First of all, if we use present worth, we need to set present worth is equal to zero and solve for the interest rate. The present worth of cash outflows may be equated to the present worth of cash inflows. That is, solve for rate of interest using either of the relations. So present worth is equal to zero or present worth of outflows is equal to present worth of inflows. We can use either of these equations to find rate of return. If we use annual worth, the equations will be annual worth is equal to zero or annual worth of outflows is equal to annual worth of inflows. We can use present worth or annual worth. The result will be the same. Calculating ROR. ROR can be calculated by one of the following two methods using present worth or annual worth, by using spreadsheet functions or by using trial and error. So we'll not go to spreadsheet function because in exams, normally when you are in classroom or you are in exam hall working on your exam or quizzes, you are not having computers. So we'll focus on trial and error methods. The general procedure for using a present worth based equation is as follows. First of all, we have to draw a cash flow diagram. Second, set up the internal rate of return equation, that is present worth is equal to zero or annual worth is equal to zero or present worth of inflows is equal to present worth of outflows or annual annual worth of outflows is equal to annual worth of inflows. You can use any of these equations. Then we have to select values of interest rate by trial and error until the equation is balanced or until the result is zero. You can get two values for rate of interest by trial and error within which present worth is zero. For example, a rate of interest at which present worth is negative and another for which the present worth is positive for given cash flows, and then interpolate a value for rate of return which is the present worth is zero. Now we learn how to calculate rate of return using trial and error method. Here is an example. Engineers with Monarch paints have recommended to management an investment of $200,000 now in novel methods that will reduce the amount of wastewater, packaging materials, and other solid waste in their consumer paint manufacturing facility. Estimated savings are $15,000 per year for each of the next 10 years, and an additional saving of $300,000 at the end of 10 years in facility and equipment upgrade costs. We need to determine the rate of return using manual solutions. So if we see, initial investment is 200,000 at time zero. Then estimated savings, so this can be considered as outflow. because this is an investment, and estimated savings are $15,000 per year. So these can be considered as inflows, $15,000 per year for coming 10 years, and an additional saving of 300,000 at the end of 10 years. So an additional saving or one-time saving will be at the end of 10th year. So on the basis of this information, we need to determine the rate of return using manual solutions. So here is, first of all, we have drawn the cash flow. So initial investment at time zero is $200,000, and from year 1 to year 10, the company can save $15,000 every year. So this is an annual series of payment from 1 year to 10th year. Then the company can save an additional $300,000 at the end of the 10th year. So step 1 was to draw the cash flow diagram that we have drawn. Now the step 2 was using present worth for calculating IROR or ROR. We have set up the equations. Present worth is equal to 0, or present worth of outflows is equal to present worth of inflows. So that would be 0 is equal to minus 200,000, that is outflow, plus 15,000, that is inflow. And this is annual series of payment. We need to calculate present worth, so we use P over A factor. Then 300,000 at the end of 10th year. So this is a single payment and a future amount. For converting into present amount, we use P over F factor for unknown rate of interest and 10 years. On the other hand side, present worth of outflows is equal to present worth of inflows. So outflows are 200,000. They are already in terms of present worth because at time zero, so this will come as it is. 200,000 would be equal to 15,000 into P over A factor for unknown rate of interest and 10 years, and 300,000 P over F factor for unknown rate of interest and 10 years. To solve these equations, we need rate of interest or rate of return that must be calculated on the basis of trial and error. For the first try, we need a good guess to start with, and guidelines for good start. For this, we need to remember and keep in mind every time solving such problems the nature of the relationship between present worth and rate of interest or discount rate. As we have established this fact earlier, that there is a negative relationship between interest rate and present worth. So if we need to come closer to the zero, we have to increase the rate of interest to get present worth equal to 0. Now, always remember the negative relationship between discount rate or interest rate and present worth. Start working with the low rate, let's say 8% or 9%, and check if the value is very negative or positive. If the value is positive, start increasing the rate of interest, so it will come down. If the value is negative, that's fine. Then accordingly decrease or increase the discount rate for the next try, keeping in mind graph shown. Get one positive present worth close to 0 and one negative present worth close to 0, and interpolate for getting unknown rate of interest for which present worth is equal to 0. Or use guideline method for good start given in book. I will explain this method in coming slides as well. So using direct method provide two values for rate of interest within which present worth is 0. For example, an interest rate at which present worth is negative and another at which present worth is positive. For given cash flows, and then interpolate a value of I for which the present worth is 0. This method is recommended because this is easy to apply. You will see the difference between both methods. So present worth is equal to 0. 0 is equal to minus 200,000 plus 15,000 P over A factor. with unknown rate of interest in 10 years and 300,000 P over F factor for unknown rate of interest in 10 years. This is the equation that we set up earlier here in this slide. So we are using this equation. Now we have to start guessing the rate of interest. Let's try with 8%. So 0 is equal to present worth and minus 200,000, 15,000 P over A factor for 8% and 10 years and P over F factor for 8% and 10 years with $300,000. So P over A factor for 8% and 10 years is 6.7101 and P over F factor for 8% and 10 years is 0.4632. Now, after making these calculation, present worth is 39,611.5. That is greater than 0. So we have uh, a rate of interest at which present worth is positive. Now we need to guess a rate of interest at which we make it present worth less than 0 or negative. So what we can do if we have a positive present worth and we need to convert it into negative rate of interest, keeping in mind the relationship between present worth and rate of interest. It means we have to increase the rate of interest to decrease the value of present worth. So let's try with 12%. Minus 200,000 plus $15,000 P over A factor for 12% and 10 years plus $300,000 P over F factor for 12% and 10 years. So P over A factor for 12% and 10 years is 5.6502 and P over F factor for 12% and 10 years is 0.3220. Here we have a negative present worth that is $18,647 and this is less than 0. Now we have two interest rates. For one we have a positive present worth and other we have negative present worth. So we can use this formula to calculate internal rate of return or rate of return. So this is R1 plus present worth 1 multiplied by second rate of interest minus first rate of interest divided by first present worth minus second present worth. So first rate of interest is 8% plus first present worth is 39,611.5 multiplied by difference of the rate 12% minus 8%. So that is 4 divided by difference of present worth 39,611.5 minus 18,647. So the unknown rate of interest or rate of return is 10.72%. So this is the rate of interest at which the present worth will be equal to 0. If we use the book method or spreadsheet method, the result will be equal to 10.58% or 10.55%. There is slight difference due to trial and error method used here. Now we'll discuss the method given in book. First of all, we have to convert the given cash flow into P over F, P over A or A over F relation by ignoring the time value of money. Here, keep in mind that according to the book method, we have to ignore the concept of time value of money and write the equation on the basis of present worth, annual worth, or future worth relation. Then we'll set the equation P over F, P over A, or A over F factors and use the tables to get the value of I. This I will be a good starting guess for the trial and error method. First of all, convert all cash flows to future because future is quite big and rounding off A will have minimum errors due to neglecting the time value of money. Here we now present worth is 200,000, number of years are 10 and future worth is equal to 15,000, 10 annuities of 15,000 plus 300,000 at the end of 10th year. So the present worth will be equal to 200,000 straight away, and if we need to calculate future worth by ignoring time value of money. So we do not need to use any interest rate or factor value, just multiply this 15,000 by 10 and you will have 150,000 and 300,000 is already at the end of 10th year, so this is also a future amount. So the future value is 450,000 and present value is 200,000 and number of years are 10. Now if we write the equation, present worth is equal to future worth into P over F for rate of interest and number of years. So by ignoring the time value of money, the equation will be 200,000 is equal to 450,000 P over F into unknown rate of interest and 10 years. So from here we can get a factor value for P over F, factor for 10 years for unknown rate of interest. So the factor value will be 0.4. Now what we need to do, we need to look in factor for P over F factor for 10 years, where we can get two factor values, one that is higher than this value and the other one that is lower than this value, are the two values between which this value will fall. Now if we see factor P over F factor for 8% and 10 years, the value will be 0.4632, which is higher than this value. Now, if we increase the rate of interest, let's say 9%, P over F factor for 9% and 10 years, the factor value will be 0.4224, which is less than this value. So now we have two estimated rate of interest, 8% and 9%. So the actual rate of interest is somewhere between 8% and 9%. So we can use these interest rates to calculate rate of return. Therefore, we will use 9% as first try. So this is the equation that we used earlier. 0 is equal to present worth. So 0 is equal to minus 200,000 plus 15,000. P over A factor for unknown rate of interest and 10 years plus 300,000 P over F factor for unknown rate of interest and 10 years. So P over A factor for 9% and 10 years and P over F factor for 9% and 10 years. The resulting amount will be 22,986, which is greater than 0. So we have one positive value. Now let's try 11% to get a negative value. So P over A factor for 11% and 10 years and P over F factor for 11% and 10 years with these amounts. So the result will be, this amount will be less than 0, which is minus $6,002. Now we have two present worths and two rate of interests. We can apply the formula. First rate of interest plus first present worth multiply the difference of rate of interest. So 11% minus 9%, 2% divided by difference of present worths. 22,986 minus $6,002. So the rate of interest will be 10.58%. As I explained earlier that from book method, this is 10.58%, slightly different than the trial and error method we used earlier. Now, procedure for getting good start for trial and error method. First of all, we have to convert all outflows and inflows into their single amounts. Present worth or future amounts are uniform amounts. By neglecting the time value of money, then we'll combine inflows and outflows such that it sets equation for P over F, P over A or A over F. Then we'll use the factor tables to find the approximate interest rate at which P over F, P over A or A over F value is satisfied. Then the rate obtained is a good estimate for the trial, for the first trial. Note, it is important to recognize that this first trial rate is only an estimate of the actual rate of return, because the time value of money is neglected and you need to get two factor values from the factor tables for the same factor and rate a number of years. One higher than that factor value and the other one lower than that factor value that you estimated. Now, as we have experienced that the rate of interest calculated by trial and error and by book method are slightly different. So how much deviation from original values is allowed? Since most of you will be calculating ROR manually during exams, quizzes, or assignments, so we will not be getting accurate values for the rate of return, but some close approximation. So to me, plus minus 1.5% difference from exact value is okay. In real situation, you will be doing that through MS Excel, so will not have such problems in real time while working on projects by using gadgets such as softwares, Microsoft Excel, or any other accounting or finance software. Greater differences than the above stated limit will be treated as wrong answer, though you may get calculation or method marks, but you cannot get maximum marks or full marks for the question. So if the value of internal rate of return is 15% and you calculated 13.5% or 16.5% or something in this range, it will be treated as correct. If the difference is more than plus minus 1.5%, this will be considered incorrect. So that was the method how we can use present worth or annual worth to calculate rate of return for a single project. Hope you understand these concepts. If you have any questions, you are welcome to write me through email or WhatsApp group, and I will try to respond to your queries as soon as possible. Okay, I think we got some time. We can solve another equation or problem. Here is a question that we can solve. So we need to determine the rate of return for the cash flows shown in the diagram by using present worth for your calculation. So here we have $3,000 at time 0, and at time 1 we have nothing. At time 2 we have $200. Time 3 we have again $200, and time 4 we have $200. So this is a series of annual payments from second year to fourth year. Then we don't have anything at fifth year, and from 6th to 8th year we have a series of annual payments, $90 each. And finally at the end of 8th year we have $7,000 additional cash inflow. And here how to solve it. If you remember the steps that we need to follow, first of all, write the equation of present worth and equate it to 0. Solve it for different rate of return that satisfy this equation using trial and error. Then do not forget the negative relation between present worth and interest rate while making guess for rate of interest that we will use in trial and error method. Let's start with cash flow diagram. Here is an equation. Present worth is equal to 0. So minus 3,000 at time 0, it will come as it is. And this is an annual series of payment for 3 years. So 200 P over A factor for unknown rate of interest and 3 years. So this will come at time 1 and we need to get it at time 0. That's why we use P over F factor for 1 year with unknown rate of interest. Then we have annual series of payment from 6 to 8 year. So $90 P over A factor for unknown rate of interest and 3 years. So this will give us the value of present worth at 5 years, and we need to convert it at time 0. So we'll use P over F factor for 5 years and unknown rate of interest. And again, 7,000 at the end of 8th year. So we need to get it at back time 0, and we'll use P over F factor for unknown rate of interest and 8 years. So this is our equation. Now we need to start guessing the rate of interest, for which we'll have one positive present worth and one negative present worth. Let's try with 5%. So by using 5% rate of interest, at 5% P over A factor for 3 years is 2.7232, and P over F factor for 5% and 1 year is 0.9524. And P over A factor for 5% and 3 years is 2.7232, and P over F factor for 5% and 5 years is 0.7835. and P over F factor for 5% and 8 years is 0.6768. And here we have this value that is equal to $1,027.10, and this is greater than 0. It means we have one positive value at 5%. So to get negative present worth, we need to increase that rate of interest. Now let's try 10%. At 10%, the P over A factor for 10% and 3 years is 2.4869, and P over F factor for 10% and 1 year is 0.9091, and P over A factor for 10% and 3 years is 0.4869, and P over F factor for 10% and 5 years is 0.6209, and P over F factor for 10% and 8 years is 0.4665. Now we have calculated, after solving this equation, the present worth that is negative and less than 0, that is $325.6. Now we can use the formula or interpolate. So rate of interest will be equal to first rate of interest plus difference of rate of interest 10% minus 5% multiplied by first present worth, that is $1,027.10, divided by difference in present worth, which is $1,352.7. So the rate of interest will be 8.79%. So this is known as rate of return or internal rate of return. If we use this rate of interest to solve this equation, the present worth will be equal to 0. Here we can calculate this even through the formula. First rate of interest is 5%, second rate of interest is 10%, first present worth is $1,027.10, and second present worth is minus $325.6. So here is the formula: rate of return is equal to first rate of interest plus first present worth multiplied by difference of rate of interest divided by difference of present worth. So 5 plus 1027.10 multiplied by 10 minus 5 divided by 1027.1 minus 325.6. So rate of return will be equal to 8.79% in either case. Hope this is clear for everyone how we can use present worth to calculate rate of return. If you have any queries or anything is unclear, you can write to me using email address or just drop a text in WhatsApp group. I will try to respond as soon as possible. Till then, stay safe. We'll see you with the next lecture, inshallah. Allah Hafiz.